We have heard space is a very harsh environment.
In space, failure is not an option.
What are we doing to enable the space scientists of tomorrow?
Education should be the key and focus that we can generate the next generation of engineers.
Hey Jayraj, welcome to Apla Pune, welcome to Ansys.
Hello Jayraj, welcome back to Pune. Today we are going to talk about space. I learned you were recently at IEEE SPACE 2025.
Yeah.
How was it?
Super good. First of all, thank you for having me here in Pune. I love to come here, even though it's not the mango season. Space 2025 was super fun because it was an opportunity to learn about so many net new technologies with net new partners. I had an opportunity to sit down with Dr. Somnath and discuss some of the adventures of ISRO. It's amazing. I learned about something called Space Mission Analysis and Design, SMAD, and why SMAD is pursued in order to reduce the risk of the mission, because in space, failure is not an option, and more importantly, you have to get it right the first time.
So you mentioned space mission analysis and design. Can you elaborate some of the elements of it?
Yeah, I mean, it's a broad field. I mean, let's take a simple scenario of launching a satellite to a low Earth orbit. You have different elements of defining and understanding the orbit to place the satellite in. So launch to orbit is one aspect that can be simulated. You have to determine the various satellite constellations and the collision avoidance mechanisms to get there. In addition, I think everything to do with space reveals a very harsh environment. So your hardware and software needs to go through certain reliability aspects to survive in that environment. Communication systems, systems engineering, the core mission parameters success depends on how well SMAD is done. And it's what researchers and engineers in space do.
It has been 5 decades since ISRO launched Aryabhata. Isn't the fundamental maths the same?
I guess so. I think some of the fundamental math is the same, but what has changed with the new ways of digital mission engineering is you now have immense compute capability in your hand. So like in the older days, an engineer would do some hand calculations and produce a few hundred output. But now with the compute capability and cloud compute capability at hand, we have millions of outputs being produced. So this statistical sample set is much larger. It helps you reduce the margins and get tighter tolerances on mission parameters. So for example, you can carry now less fuel, an optimized amount of fuel to achieve the mission objectives, which has a direct impact on the launch vehicle, the payload, and its capabilities.
We have heard space is a very harsh environment. What role does engineering simulation have to play in there?
Yes, space is harsh. We always think of Earth where we have breathable air, but this atmosphere actually helps us shield and protect against the harsh radiation. In space, it's about 15 times more. The temperature also is about, on an average, minus 450 degrees Fahrenheit. So overall, the electronic subsystems that we send up there need to go through assessments on reliability, and we have to have the shielding technology to prevent them from getting disrupted. You know, in space, we can't call a support center to come and do a hands-on fix. It's uncrewed, and there is no support service readily. So you have to get it right and make sure the systems are reliable. Also, when you send these payloads up in space, the rocket produces so much thrust. A simple thing like shock analysis, vibration analysis is so important to make sure that these parts don't come apart by the time they get to space.
Since IEEE SPACE 2025, we have seen a very successful launch of Nair by ISRO, which has been an excellent example of collaboration between NASA and ISRO. Can you comment on how's the collaboration between different space agencies?
It's very robust. In fact, this is not a one event success, right? The Nair project has been going on for years. It's the synthetic aperture radar, a satellite that has been launched, which has the L-band from NASA. It has the S-band capabilities from ISRO, plus the launch vehicle was ISRO's, plus the launch services were ISRO's. I think it is a good example of how humankind can benefit from the collaboration between agencies across the world. For such collaborations to be seamless, the fundamental capability of digital engineering is important. You have to be able to have designs, systems, IP blocks, capabilities kind of digitized that can be ported and shared with different functional groups in different parts of the project, right? So across ISRO or NASA. Similarly, I can see in fact was happy to hear from Dr. Somnath about Chandrayaan 5, which is a collaboration between JAXA and ISRO, which is coming up. I'm based in Tokyo, so I'm excited and looking forward to working with that project as well. So the point is, digital engineering and model-based simulation engineering is at the core of enabling collaboration across agencies. Everybody is excited about space. I think it's growing as much as the semiconductor and electronics industry, if not more. And we should support it by going digital first.
So far, we have spoken about technology, processes. Where do skills fit in? What are we doing to enable the space scientists of tomorrow?
Well, the complexity of the systems is growing, so you need multidiscipline skills. Ansys is very proud to support different content generation, curriculum creation, as well as competitions, hackathons. I remember the CanSat competitions that we support with Astronomical Society of India, I think. And those enable new kids to try out different, technologies at the same time, learn about new ways of working. I think this entire area is becoming more and more multidisciplinary. It always has been. It's just the ability to do some concurrent engineering of the different stages of a design and collaborate across people. That needs a revised focus. So as industry, we need to work closely with the academic world and provide the tools and techniques to get this concurrent engineering education system, multidiscipline, multi-domain kind of knowledge diffusion more easy. Education should be the key and focus so that we can generate the next generation of engineers.
Thank you, Jayraj. It was fun talking about space with you today. You have been hopping countries for Simulation World events. What are your plans for today?
I'm really fortunate I came in the middle of Ganesh festival, so I'm going to go to W Shade and watch Ganesh this evening and have some modaks as well.